are you? I will try to keep you awake, so this talk is going to be very fast. My Italian sucks, so I will not say anything in Italian, like buongiorno, that's as much, and grazie. So I'm Marcia, and I don't have time to present myself because I have only 10 minutes, so let's get started. So the first thing I want to address here is what is GraphQL? Because I want to talk about GraphQL on serverless, and maybe not of you are familiar with what is GraphQL. So I will give you a super fast introduction of what is GraphQL. The first thing to have in mind that GraphQL is a specification. It's not a framework, it's not a database, it's not a server, it's something that you will have to implement and somebody else will need to implement for you. It's a specification created by Facebook, and it was open source some years ago. So here is a diagram of an example of how GraphQL looks. So GraphQL will sit between your client and your data sources. I'm not saying servers, because a data source can be anything. It can be from an HTTP server that has an HTTP endpoint, or it can be a database, SQL, non-SQL, it can be Elasticsearch, it can be, I don't know, some third-party service that returns data to you, so it's something that returns things. And GraphQL will be sitting in the middle, connecting all these different data sources to making one entry point for your client. So between the client and the GraphQL, they need to sign a contract, so then the client knows what they can ask from the GraphQL. So this contract is called a schema. In the schema, you will find two important things. You will find all the types that the client can ask from the backends. So, for example, we are building an e-commerce platform. We will have in the types the orders, the products, I don't know, the providers, your profile, and things like that. And each of these types, we have different attributes defined. And then also in the schema, you can find all the operations the client can perform in the backend. So let's buy a product. Let's search for a product. Let's do, I don't know, I want to retrieve all the orders in the last 6 months. So that's in the schema. And then in order for this data to arrive to the client, you need to create what is called resolvers. The resolvers are these kind of ways to translate the GraphQL request to the data sources, and the data sources response to the GraphQL in a GraphQL response, so it can go to the client. So for example, if we want to fetch all the orders that we have done in the last 6 months, and our data source is an SQL database, what we need to do is to build a resolver that knows how to open the database connection, and it will grab the GraphQL request and translate it to something that SQL understands. So it will be like select blah, 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 blah from orders table where blah, 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 blah. And that will return like a list of items. And then the resolver will need to translate that list of items into something that in general is a JSON that is a response from GraphQL to the client. So the resolvers and the schema are two important parts of your applications. They are unique for your application, and that's something very important to remember. Some concepts is that you can describe in the schema everything using a type system. GraphQL is a strongly typed language, so everything is defined and it has a proper type. Either it's a kind of basic type, string, integer, boolean, or it's another type. And then the client can ask exactly for what they want, so they don't need to, when they are getting like the orders in the last 6 months, they don't need to get all the information that comes from the order, but they can ask for exactly what they want. They can ask, I want the order ID, and I don't know, what was the products that were there? And you can get exactly that. So that prevents the overfetching of information. And then in the other hand, whenever we get for example, the orders that we want on the last 6 months, then we will get in the one request, you can get the orders, and inside the orders, maybe the products, and maybe the provider, and maybe some other information, and you will get everything you need in one request, so we are not underfetching. So now let's talk a little bit about the serverless promise. I will refresh at least my definition of what serverless promise. I think we will discuss that all day if we want. That is not managing infrastructure, it's paying for what you use, and automatically scaling. So there is 3 types in my head on how you can implement this GraphQL. So the first type is the hardcore guy that wants to have GraphQL in COBOL and will grab the specification and will type it in COBOL and write the schema and write the resolvers, then put it in a server, scale it, maintain it forever, and live happily ever after. Luckily, that's not the most common way to implement GraphQL, because why implement the wheel all the time? The most common way to implement GraphQL is to use an existing GraphQL library, Apollo or whatever. You can choose it in many languages. There is Java, JavaScript, Go, whatever. I don't know if there's COBOL. And then you grab that, you write your schemas, you grab your resolvers, you write them yourself because they are important for your application. You put that in a server, you maintain it, you live happily ever after. Luckily, now there is a new way to do GraphQL implementation that is letting somebody else to implement it for you, and then writing the schema and the resolvers, and that's it. So that's what I will be talking about today, because I only have 10 minutes. So I will be talking about ABsync, that is the managed GraphQL platform by AWS. So ABsync provides everything that GraphQL provides, so I will not get into that. And it provides authentication out of the box. That's very important if you are creating client applications. You won't want to let your information in the wild. It has a visual tool for queries. It also supports different types of data sources, like the HTTP, but it also provides connections to RDS, Dynamo, Serverless Search, Lambda, and things like that. And it also has support for real-time and offline. So that's very good if you are managing clients' applications. So this is an architectural diagram of a very simple ABsync scenario. We have the client, it connects to ABsync, and then we have this VLT, it calls Velocity Language Templates. Those are resolvers. Because we are using a managed service, we cannot decide in which language this is going to be written. AWS decided that it's going to be Velocity Language Template for writing these resolvers. So you need to write a resolver for the response and a resolver from the request. And we have two data sources, one for Lambda and one for Dynamo in this schema. This is how the console looks. And in here, I put you a schema, an example of a very simple schema. We have the type task, that we can have an ID and a description. And then we have queries. Queries are operations that doesn't have side effects. So we have to get a task. And also the hello world that will connect to Lambda and just will display hello world. And then the mutations are operations that have side effects. And in this case, we have create a task. This is how it looks for our data sources. We have one DynamoDB and Lambda. I will show you a little bit more into details of this. And this is how we write a query. So we go to the query tool. This is from our server before we give it to the client, but then the client can grab exactly these queries that you have written here and implement them on their side. So you can get a task. Oh, there is nothing. This is going to the database, so our data sources are empty, Dynamo table. And then we can write a mutation to create a task, so we can get something back. And there, we just create a task called that operation. And then all the operations are returning some type. And there, in this case, the create a task returns a task. And we will decide that we want to have the task ID and the description in the back. I'm slow typing. So when we get that, we will get the task ID. And then we can pass the task ID to the get a task. And you will get a task back. I will not show you that. You can imagine it. Then the proper way of making applications, production-ready applications, is to have infrastructure as code. So you don't want to go to the AWS console and click, 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 because then you need to do it for staging, for production, for development, for your casting, and it's very hard. So what you want to do is you want to write a document that has all your infrastructure, change some parameters, and voila. So this is how it looks. This is a serverless framework. You can do this with some or with other frameworks, because it supports CloudFormation ABsync. And this is how you do it. So you have to install this plugin, Serverless ABsync. And then you put a custom property where you will define all your ABsync thing. So the first thing we have is the name of your application. Then we have the authentication type. This is an API key. Then the name of the schema. Then we have the mappings, that is the resolvers, and the data sources. Here we will define the Lambda and the DynamoDB. If you go down in this YAML, you will see that DynamoDB table is defined in the same file, and Lambda is also defined there. So this is great. Now we have our, all our infrastructure in one place. And then we can see that those are our resolvers. We have free resolvers because we have free operations, the hello world, the get a task, and the create a task. So hello world is calling Lambda, and this is our request. It's invoking this Lambda with those parameters. Super simple. This is how Velocity template look. And this is our response. Whatever Lambda returns, we just show it out. The same will happen with the get task, but instead of calling Lambda, it's calling Dynamo. So we can see that the resolver, instead of doing an invoke, is doing a get item, and is passing a task ID that is coming from the argument. So it's very, very straightforward. After you start learning how Velocity templates work, they become very natural, and there is a lot of things that you can do. You can do authentication. You can do piping all things together. So how the client use this? You use the library AWS Amplify. There is a client library for building cloud apps. You should check it out. But basically, you just can put this configuration in the client that you get from the settings, like the URL, the region, and the authentication type, and voila, it's configured. Then you just write the queries that you have tested in your ABsync query tool. You put them in a file, and then you do client, whatever, query or mutation or whatever, and it works. Very simple. Things to have in mind. If you're using Dynamo, don't do scan. That's not a good idea, so please don't do it. It's very slow. That's very normal. People like to do. People complain about calling lambdas. I never had that problem, but well, I just transferring the information. Doing an HTTP call will add some latency because you are connecting to the internet, so be aware of that. Don't expect magic things to happen. There is time and distance in the word. And try to learn how to use velocity templates. Don't do, because I have seen it, that people have a data source that is Lambda that then is using the AWS SDK to connect to Dynamo. So why you need the Lambda in the middle? You can just connect from ABsync to Dynamo. So try to think how you can optimize your application using as much as you can from velocity language templates. And thank you all. And this is my Twitter. Ask me questions there because I don't have time for that. Thank you.